Welcome to
KidMath number 10.
KidMath number 10. So we moved on to section 10.3 of our problem solving algebra book today. And we're talking about slightly more complicated quadratic expressions. In particular, the complication, the extra complication here is the first, the coefficient on the x's. That's what I'm trying to say, is not 1. Okay, so let's see. First of all, can you show how to multiply this out, please?
Well, you do 6x times 2x, which is 12x squared. And then 6x times 15 plus 90x.
Okay.
Then plus 14x.
Okay, good.
Plus 7 times 15, which is 105.
105. Okay, so just to show what you did 6x times 2x, that's the 12x squared. You did 6x times 15, that's the 90x. You did 7 times 2x, that's the 14x, and 7 times 15, which is the 105. And what does this end up equaling? Can you write a little bit larger than you've been writing?
12x squared plus 104x plus 105.
Okay, great. So we get this expression, 12x squared plus 104x plus 105. And this is definitely more complicated than the expressions we've been studying over the last couple days,
Yes.
right? Okay. And part of that complication is coming from the fact that the x squared term is not equal to 1. Okay, so now you can really see on this one, if I ask you to solve this equation here equals 0, that seems like that might be pretty difficult.
Hard to do.
Fortunately, for this specific one, there's an easy trick. What is it?
Well, 104 is 12 times 8. Like that.
No, 12 times 8 is 96. So I ask you to solve this expression, equals 0. What would you do?
Well, we need to find the roots.
We do need to find the roots, but it's going to be very difficult to do unless we do what?
How can we factor something out?
Right, let's try to factor this. I wonder if this factors into something nice.
This factors this.
Oh, it came from this. So in this particular case, this is 6x plus 7 times 2x plus 15, and we already knew that.
Yes.
Okay, so what value of x makes this equal to 0? X equals,
Well, you need 6 times something plus 7.
okay, write that out. You need 6x plus 7 equals 0. Okay, what value of x makes that equal to 0?
6x is 7, so x equals 7 sixths.
Okay, plug that in for me.
Let's see, so 6 times 7 sixths, that's 14.
Strange. Okay, so why don't you try solving it one more time?
Well, 6x plus 7 equals 0.
Okay.
So 6x is negative.
Oh, the negatives. Okay. So what does x equal?
X is negative.
Negative 7 sixths.
So then the 6 cancels. So yeah, it is 0.
Okay, that's why it's always good to check. Sometimes you can make little mistakes with minus signs and things like that. What x makes this equal to 0? See if you can just tell me.
15 halves. Negative 15 halves.
Negative 15 halves. Okay, so x equals minus 7 sixths and x equals minus 15 halves make this equal to 0. Not super easy to see from this, right?
Yes, but easy to see from this.
From when you factor it. And the only reason this was easy to factor is because it came from something that was factored. So now we're getting into stuff that's genuinely difficult. Okay? And this goes back to what I'm saying, and why this is an interesting problem is because it goes back to the original factoring problem. It's not necessarily easy to see that 91 is what the factors are unless I tell you that that's 7 times 13, right?
Yeah.
7 times 13, it's easy to know what the factors are
Because they're prime.
91, it's not super easy to see. Same thing here. It's easy to see what the roots of this equation are, or the factored equation are, but it's hard to see what the roots of this is. This is why this is an interesting problem. Okay? Over the next month or so, we're going to learn how you solve problems like this. Okay?
Right.
All right, good job. Good job.